Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you Coordinate Geometry of Straight Lines Part 1. From definition, coordinates are two numbers which give the position of a point on the Cartesian plane or graph, showing a plane surface with two axes, that is, the x-coordinate and the y-coordinate. The x-coordinate is the first number which gives the distance of the point along the x-axis, that is the horizontal axis, while the y-coordinate is the second number which gives the distance of the point along the y-axis, that is the vertical axis. Also from definition, geometry is the study of the properties of shapes such as lines and angles. A straight line is a line which goes in the same direction. Let's learn more about coordinate geometry of straight lines. Let's learn about the formulas for number 1, distance between 2 points, number 2, coordinates of midpoint of a straight line, number 3, gradient of a straight line. For number 1, let's see the formula for the distance between 2 points. The distance or length L of the straight line between 2 points, point P having the coordinates x1, y1 and point Q having the coordinates x2, y2 is L is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Please take note of this formula for the distance between 2 points. Let's see our second formula for coordinates of midpoint of a straight line. The coordinates of the midpoint of a straight line joining 2 points, point P having the coordinates x1, y1 and point Q having the coordinates x2, y2 is x1 plus x2 all divided by 2 representing the x-coordinate of the midpoint and y1 plus y2 all divided by 2 representing the y-coordinate of the midpoint. Please take note of this formula for the coordinate of the midpoint of a straight line. Let's see our third formula for gradient of a straight line. From definition, the gradient or slope of a straight line is a measure of the steepness of the line. The gradient or slope of a straight line is the same at any point on it. Let's see the formulas for the gradient of a straight line. The gradient or slope of a straight line passing through 2 points, point P having the coordinates x1, y1 and point Q having the coordinates x2, y2 is given by m, where the first formula for the gradient m is equal to increase in y from P to Q divided by increase in x from P to Q. The second formula for the gradient m is equal to difference in the y coordinates divided by difference in the x coordinates. The third formula for the gradient m is equal to the rate of change of y compared with x. Let's see more formulas for the gradient of a straight line. The fourth formula for the gradient of a straight line m is equal to y2 minus y1 divided by x2 minus x1. The fifth formula for the gradient of a straight line m is equal to y1 minus y2 divided by x1 minus x2. While the sixth formula for the gradient of a straight line m is equal to tan theta, where theta is equal to the angle between the straight line and the horizontal or x-axis. Please take note of all these formulas for the distance between 2 points, coordinate of midpoint of a straight line, and gradient of a straight line. Meanwhile, let's learn more about the gradient of a straight line. The gradient or slope of a straight line may be positive, negative, 0 or undefined. Next, let's see how a positive gradient or slope looks like. From the Cartesian plane or graph, a straight line rising upwards from left to right on the Cartesian plane has a positive gradient or slope. Next, let's see how a negative gradient or slope looks like. From the Cartesian plane or graph, a straight line falling downwards from left to right has a negative gradient or slope. Next, let's see how a zero gradient or slope looks like. From the Cartesian plane or graph, a horizontal line has a zero gradient or slope. Next, let's see how an undefined gradient or slope looks like. From the Cartesian plane or graph, a vertical line has an undefined gradient or slope. Please take note of all this information involving the gradient of a straight line. Next, let's see some examples on coordinate geometry of straight lines. Our first example is on distance between 2 points. Example 1. Find the distance or length between each pair of points. Question A. The coordinates of the first point are 7 and 2, and the coordinates of the second point are 1 and 6. And question B. The coordinates of the first point are 3 and minus 3, and the coordinates of the second point are minus 2 and 5. Let's see the solution to question 1A. Let the coordinates 7 and 2 be our point 1. That means that x1 is 7 and y1 is 2. Also, let the coordinates 1 and 6 be our point 2. That means that x2 is 1 and y2 is 6. Next, can you remember the formula for the length L between 2 points x1, y1 and x2, y2? Let's see if you can. The formula for the length L between 2 points is L is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. I hope you got that right. Next, when you substitute the values x1, y1 and x2, y2 into your formula, what will be the distance or length between the 2 points? Let's see if you are right. Substituting the values x1 is equal to 7, y1 is equal to 2, x2 is equal to 1 and y2 is equal to 6 into the formula for the distance or length between the 2 points, we are going to have L is equal to the square root of 1 minus 7 all squared plus 6 minus 2 all squared. That will give us the square root of minus 6 squared plus 4 squared, which will give us the square root of 36 plus 16, which will add up to the square root of 52. The distance or length between the 2 points is 7.21 units. I hope you got that right. Next, let's see the solution to example 1b. In example 1b, let the coordinates 3 and minus 3 be the first point. That means x1 is equal to 3 and y1 is equal to minus 3. Also, let the coordinates minus 2 and 5 be the second point. That means that x2 is equal to minus 2 and y2 is equal to 5. When you substitute these values into the formula for the distance or length between the 2 points, L is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. What will be the distance or length between the 2 points? Let's see if you are right again. Substituting the values x1 is equal to 3, y1 is equal to minus 3, x2 is equal to minus 2, and y2 is equal to 5 into our formula, the distance or length between the 2 points will be L is equal to 9.43 units. I hope you got that right again. Please take note of the solutions to example 1A and B. Next, let's see our second example involving the coordinates of midpoints of a straight line. Example 2. Find the coordinates of M, the midpoint of the straight line, joining point P, having the coordinates minus 1 and 4, and point Q, having the coordinates 5 and minus 2. Let's see the solution to example 2. Let point P having the coordinates minus 1 and 4 be our point 1. That means that x1 is equal to minus 1 and y1 is equal to 4. Also, let point Q having the coordinates 5 and minus 2 be our point 2. That means that x2 is equal to 5 and y2 is equal to minus 2. Next, can you remember the formula for the coordinates of the midpoint of a straight line joining 2 points x1, y1 and x2, y2? Let's see if you can. Of course, the coordinates of the midpoint of a straight line is x1 plus x2 all divided by 2, representing the x coordinates of the midpoint, and y1 plus y2 all divided by 2, represent the y coordinate of the midpoint. I hope you got that right. Next, when you substitute your values for x1, y1 and x2, y2 into the formula for the coordinate of the midpoint of the straight line, what will be the coordinate of the midpoint of the straight line in example 2? Let's see if you are right. When you substitute the values x1 is equal to minus 1, y1 is equal to 4, x2 is equal to 5, and y2 is equal to minus 2 into the formula for the coordinates of the midpoint of the straight line, x1 plus x2 divided by 2 and y1 plus y2 divided by 2, we are going to have minus 1 plus 5 divided by 2 and 4 plus minus 2 divided by 2. That will give us 4 over 2 for the x coordinates and 4 minus y over 2 for the y coordinates. That gives us 2 for the x coordinates and 2 over 2 for the y coordinates. Lastly, the coordinates of M, the midpoint of the straight line, are 2 and 1. I hope you got that right. Please take note of the solution to example 2. Next, let's see our third example involving the gradient of a straight line. Example 3. Find the gradients of the straight lines joining the following pairs of points. In question 3a, the coordinates of the first point are 2 and 3, and the coordinates of the second point are 6 and minus 5. In question 3b, the coordinates of the first point are minus 7 and minus 4, and the coordinates of the second point are minus 7 and 8. In question 3c, the coordinates of the first point are minus 2 and 2.5, and the coordinates of the second point are minus 3.5 and minus 5. While in question 3d, the coordinates of the first point are 4 and 9, and the coordinates of the second point are minus 1 and 9. Let's see the solution to example 3a. In example 3a, let the coordinates 2 and 3 be points 1. That means that x1 is 2 and y1 is 3. Also, let the coordinates 6 and minus 5 be point 2. That means that x2 is 6 and y2 is minus 5. Next, can you remember the formula for the gradient of a straight line joining the points x1, y1 and x2, y2? Let's see if you can. The formula for the gradient of a straight line is y2 minus y1 over x2 minus x1. I hope you got that right. Next, let's substitute the values for x1, y1 and x2, y2 into our formula for gradient to find the gradient of the straight line joining the 2 points. When you substitute your values, the gradient of the straight line is minus 5 minus 3 divided by 6 minus 2, which will give you minus 8 divided by 4. The gradient of the straight line is minus 2. I hope you got that right. Apart from using the formula y2 minus y1 over x2 minus x1 for the gradient of a straight line, can you remember the second formula that we can use for the gradient of a straight line? Let's see if you can. The second formula for gradient is y1 minus y2 over x1 minus x2. I hope you got that right. Once again, substitute your values for x1, y1, x2, y2 into your second gradient formula. What will be the gradient of the straight line joining the 2 points in example 3a? Let's see if you are right. When you substitute your values for x1, y1, x2, y2 into your second gradient formula, the gradient of the straight line joining the 2 points in example 3a remains minus 2. I hope you got that right. Next, let's see the solution to example 3b. In example 3b, let the coordinates minus 7, minus 4 be our point 1. That means that x1 is equal to minus 7 and y1 is equal to minus 4. Also, let the coordinates minus 7 and 8 be the second point. That means that x2 is equal to minus 7 and y2 is equal to 8. When you substitute these values into the gradient formula y2 minus y1 over x2 minus x1, what will be the gradient of the straight line joining the 2 points in example 3b? Let's see if you're right. The gradient of the straight line joining the 2 points in example 3b is equal to 12 divided by 0, which will give us an undefined gradient. Hence, the gradient of the straight line in example 3b is undefined, representing a vertical line. I hope you got that right again. Please take note of the solution to example 3b. Next, let's see the solution to example 3c. In example 3c, let the coordinates minus 2 and 2.5 be our point 1. That means that x1 is equal to minus 2 and y1 is equal to 2.5. Also, let the coordinates minus 3.5 and minus 5 be our point 2. That means that x2 is equal to minus 3.5 and y2 is equal to minus 5. When you substitute these values into the formula for gradient, which is y2 minus y1 over x2 minus x1, what will be the gradient of the straight line in example 3c? Let's see if you're right. When you substitute your values for x1, y1 and x2, y2 into your formula for gradient, the gradient of the straight line joining the 2 points in example 3c is 5. I hope you got that right. Next, let's see the solution to example 3d. In example 3d, from our first point, x1 is equal to 4 and y1 is equal to 9. While from the second point, x2 is equal to minus 1 and y2 is equal to 9. When you substitute these values into our gradient formula y2 minus y1 over x2 minus x1, what will be the gradient of the straight line joining the 2 points in example 3d? Let's see if you are right. When you substitute your values for x1, y1 and x2, y2 into the gradient formula, the gradient of the straight line in example 3D is equal to 0, and this represents a horizontal line. I hope you got that right again. Please take note of all the solutions to example 3A, B, C and D. Let's see our last example involving the gradient of a straight line. Example 4. Find the gradient of a straight line which makes an angle of 30 degrees with the horizontal or x-axis. Let's see the solution to example 4. But before we do that, can you remember the formula for the gradient of a straight line which involves the angle between the straight line and the horizontal axis? Let's see if you can. The gradient of a straight line is equal to tan theta. I hope you got that right. Here theta represents the angle between the straight line and the horizontal axis, which is 30 degrees. That means the gradient of the straight line in example 4 is tan 30 degrees. Now checking the value of tan 30 degrees in your 4-figure table or your scientific calculator, what will be the value for the gradient of the straight line in example 4? Let's see if you got that right. The gradient of the straight line in example 4 is 0.5774. I hope you got that right. Please take note of all the solutions to the solved examples involving the coordinate geometry of straight lines. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic coordinate geometry of straight lines, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.